I'm Karen. I'm from YerevaNN. For who doesn't know about it yet, it's local, small, Kiplik research laboratory in Armenia, and we are working on different topics. And me personally, I'm working on natural language processing, and I believe that many questions in the artificial general intelligence are going to be answered in this field. And I'm really delighted to see that other modalities are getting benefits from bridging their knowledge to this natural language and text information that we already have in language modeling in other places in NLP. And today's talk is going to be about retrieval-enhanced learning. We'll talk about what it is exactly in a little bit later. At first, I wanted to introduce some things, some concepts, and this is the outline. First, we're gonna like recall some important concepts, and after that, we'll discuss some limitations and problems that we've already seen in machine learning research, and then we'll discuss some recent works that aim like on retrieval enhanced learning topics that aim to solve these problems, and in the end we'll show some new features and properties that are unlocked when adopting this kind of new approach of retrieval-based learning. So this is in some sense of a sequel of my last year's data first talk, which was called like prompt-based learning, and it was about this prompt-based learning that the main idea was here to reformulate every single NLP task into a language modeling task. It is like easy thing to do. Like sometimes it's easy, sometimes it's difficult, but it's almost every time you can do such a thing. For example, let's consider this task of sentimental analysis. So what you can do here, like this is your input, and consider you have a language model. So basically, given the context, you can predict the next word. So what you can do, you can add this phrase. Overall, this movie was, let's call this prompt, okay? And expect next word like to be predicted by the language model, either good or bad. And then look which one is more likely, okay? And that's your answer. So the idea like is as follows, and many things you can do with this. And we can notice that in this case, there are absolutely no training examples involved. So no training examples for this specific task. We had, in fact, some unannotated corpus, like you have trained in completely unsupervised fashion. So there was the training data, but not for this task. So this is why we call this zero-shot learning. Okay. And after that, we can see that also these language models are pretty good at few-shot learning in this setup. When it turns out in language models, they detect some patterns pretty well. So basically what we can do, you can expect language model to follow this pattern that is present in your input. So basically everything here is in a same context, in same input, and it notice that there is a pattern when in the left side there is an English original sentence, and there in the right side there is a translation. So basically, in order to follow and fulfill this same pattern for the continuation, it has to do like to work very hard in order to like translate this phrase into French one. So basically, in this case, you can see there are actually some training examples present, and it is like very good to see that this is effective even for very small number of sentences, and this is what we call few-shot because of this setup. And we have already seen that machine translation is able, is in the capabilities of language models and prompt learning. And even these language models are pretty good at code. I think some of you have already seen this GitHub Copilot extension. So basically, this is VS Code extension that you enable, and after that it starts to generate code for you. And it's believe me, it's insane. If you look how it generated the code, and I'm not even impressed by this example, but from my real life everyday examples of how GitHub Copilot behaves. And so basically they are pretty good at coding as well, and they are pretty good on multimodal basis. So basically in Clip they have this bridge from text models and vision models. So basically even if Clip have never seen, say, an elephant, but its text modality model has seen the Wikipedia article of elephant and read that it has 4 legs, it's gray, it's like pretty big, it has big nose. Then at first time when he's seen, it can actually then like extrapolate it and predict that it's really an elephant. So the same thing about multimodal generation, which is I'm pretty sure everyone knows what it is about. Like last year when I was talking about prompt-based learning, like not like it's like only a little part of audience was aware of what the prompt is, but right now everyone knows what the prompt is because of this DALL-E hype. It's going on in Twitter and in the internet. This one example is my favorite, like neurosurgeons putting ramen inside men's head as a joke. It's pretty great. And yeah, we can see. Yeah, and it turns out it also is pretty good at arithmetics. For example, you can do things like this. Okay, it supports basic arithmetics. Like there is absolutely no supervision here involved in any sense. And it's pretty good in question answering, and like let's discuss this kind of question answering. For example, there is a continuation for this sentence. The Second World War started in the year of 1939. This is his prediction, or GPT-3's prediction. So basically it is aware of like things that happened in the past in the history. So basically it has knowledge base about all of these things implicitly encoded in its weights. And even it knows that the first president of Armenia was Levon Petrosyan, and I was like shocked when yesterday I was trying new things, like wife of Levon Petrosyan was Nune Petrosyan, and I had to go to Google and like crash it a couple of pages in order to like verify it, like this is correct. So after this, you can see that really these kind of language models are implicitly encoding knowledge inside their parameters, which is like great. You can kind of store any kind of parameter, unlike those structured knowledge bases that you have to like add new relation types for every kind of new information. But this, as we've seen, this needs a lot of memorization, angiranel, let's call it that way. And almost all of these things, they require some kind of memorization. Okay. For example, you can code if you like already remember how to write certain logic, you can just write it, and that's it. But there are problems here. Not always it works like that example. Like for example, this where is the Bermuda Triangle? The Bermuda Triangle is in the southwestern Atlantic Ocean. Good job for saying it's in Atlantic Ocean, but it's not in northern part of Atlantic Ocean. So it is not true. And what is the name of assistant of Mr. Marshall? So basically, it's a little bit difficult. And it says Tartat the Third. But like, I mean, he was not the king at that time even. Like, yeah, it has to like write down any single thing. So the problem here maybe is because the way we train these networks. The problem is that when we train these networks, like every single sentence in these big language models, if it's seen only once, it's not like other type of deep learning trainings when you train like 30 epochs and see what's happening and worry about overfitting, right? In this case, it has to like read the same thing about sentences about same thing in order to memorize things. So there are some issues. Okay, so this is an issue with memorizing, and another problem here. Like a couple of days ago, Hambardzumyan asked me how to solve this problem. Can you think of what the problem is?
Yeah.
Why can't it predict correctly?
Why? Or there are some sources that would say that he won the election, but that election was won by Democrats.
Not exactly.
Maybe because inauguration was in 2021 and it is taken into
No. No.
Probably U.S. abbreviation is not right.
No. They used to write US this way. Yeah.
I think that is many topics in Facebook and Google that say that Donald Trump. Okay.
It's not that case either.
Is it grammar related?
Nah.
Not grammar related?
The data before 2020.
Yeah. That's it. So this is from GPT-3. GPT-3 was trained in the first half of 2020. So basically, it has absolutely no knowledge about things happened after that. Okay, so basically, it has also no ability to learn new things. Only new it's possible to give in the same context, and that's it. You have to retrain your whole model in order to be able to learn that what happened in 2020 US presidential elections, and it has to say something that is more or less probable, and Donald Trump was planning to apply, so it's 50-50 in this case. Okay, this is also a problem. Okay, and okay, I think I had to remove this, but sometimes you have some questions that can be answered. They can be answered, but they don't really require that kind of reasoning abilities or being smart, because you can just Google it. And one more example from non-pure NLP sphere, in August 31st, Manuel Avetisian, he's one of our speakers at DataFest, posted this very impressive photo of teddy bears underwater, very photorealistic. Everything is great about this. Okay, and after that, Rand commented a new photo with the prompt Manuel Avetisian speaking at DataFest Yerevan.
Well, it might have looked like this 10 years ago, 15 years ago.
Yeah, but it's not Manuel Avetisian, right? Who knows Manuel Avetisian? He knows that they are not they
There's
don't.
some similarity.
I don't think there is similarity. Okay, anyway, but who doesn't know Manuel Avetisian is maybe because of his giving his talk right now in the next door. That's why you don't know him. But if you don't know him, still you can Google him, and you can see that he's not the same person. Okay, no resemblance.
Not today.
Yeah. What's the problem here? The problem here is that learning things that they're learnings, for example, Marvel's face, if there's 2 or 3 pictures in the whole internet, is pretty challenging task when you are just training this way as we used to train language models, right? Mm-hmm. So we had to come up with some new ideas how to solve this. And there was an idea to retrieve from databases and work with the retrieved data. What we mean by retrieving? Say there's a question about that Bermuda Triangle. Okay, where is located the Bermuda Triangle? You can Google it, pick 10 top Google results, put in the context or say these are some candidates that already have the answer in it, okay? And after that, train a question answering system that will read the passage and write the answer. And this is essentially what is done in this paper, ORQA. They discuss the task of open domain question answering, which is when you are giving the query, like a question, but you don't have the passage. So basically, like, it's up to you to go to search anywhere or just remember all the answers to all the questions in this earth. So what it does, it reads the question, and then it has a database of many sentences, like corpus which was trained on, right? And after that, what he can do, it can just pick all the candidates and train a system that classifies whether this passage has the answer to this question or not. And this was pushed further in the paper of Real, and they actually this time used more prompt-based learning stuff. For example, here you can see that they are trying to not to build a like BERT classifier and train, but they are using BERT's MLM head, so mask language modeling head, and they are asking what's the masked word here. So what they can do, again, they can retrieve from a corpus, put in the same context, like so. So there's a sentence, then you append with knowledge, with something you retrieve from internet and you believe in it, okay? And you're asking what the mask is. So it is pretty easy for a model to answer this. And it's pretty easy also to do because you can, generate train BERT, BERT is already pre-trained, take their encodings and find the most likely examples, not by just text search, but with BERT vector similarity. So find the find the nearest neighbor to that point. And this paper pushes that even further and does it during the training and not during the test. It gives two good things. First, the model is getting used to having facts after the step. Okay, it's getting used to this fact and trying to use this accordingly. And second thing is that when the model is always given very helpful passage after that, it starts to offload his memoizing capabilities to the retrieval part. So basically, it right now it has no need to memorize anything. Memorize when the Second World War started, or where the Bermuda Triangle is located. Okay. Then there was a RAG paper. RAG paper is very similar to Real paper, but it's doing not in MLM way, mask language modeling way, but it uses sec-to-sec architecture, and the inputs are question, and the output is the answer. And what you do is you just pick the retrieval part and put in the context of this input. And after that, they found that it's not only suitable for these open domain question answering tasks, but it's you can use them for other tasks as well. And both these papers, they are parallel, very concurrent papers at that time, and both of them showed state-of-the-art performance on 3 of open question answering benchmarks. And this one is very recent, Retro by DeepMind. What they do, the most important thing, I guess, here is that they show that it's very efficient to scale retrieval-based learning. It's very efficient in case of that you can scale, you can have very big language models, very big knowledge bases, I mean, collection of documents, and it will work very fast. And like benefits is that it outperforms GPT-3 by having 20 times less parameters. Okay, so it's very important. So it's very, very efficient because it, like GPT-3, as you can see, it remembers like many things, and its weights is his capacity, his neural like parameters to do that. Okay, but we don't need it. And what it does, it actually does two major changes. First, it replaces more simple attention mechanisms that we used to have everywhere with chunked cross attention mechanism. I'll talk about it a little bit later. And what it does is actually it also makes it more simple collection of knowledge base. Okay, so it gets a frozen bird and passes all the documents and gets new vectors for each document, and after that it does nearest neighbor search using some libraries that are like very optimized. One of them is Vice from the Facebook, and they can do it very fast. And another thing that why they did change the architecture, because when you put in the context increases k times, right? And as we know from architecture of the transformers, the computational complexity increases in k square. So this is not good, and they managed to make it linearly by introducing this. So basically, in short, input is given. All of these examples are in the database. The input is gone to BERT, and we take the average. And after that, we take the k nearest neighbors from the database, and after that, we pass them into retro, and that's it. And we've already, and it shows that it scales pretty well with all the hyperparameters we have. And you can see it outperforms all of the pile subsets, but most importantly, GitHub. It's like, think of it, GitHub consists of code, and if you can open another code base and see, and you it's very straightforward to copy some very essential things, and it managed to solve this. But like more impressive is this next slide. The input is digits of pi, and it's able to generate number of digits after that. But the standard wasn't able to do this. Okay, so basically it's that strong from sense of like factual knowledge. So let me skip this. We have no time. Yeah, there is also retrieval-augmented diffusion models, which supposed to solve this problem with Manvel Isan speaking at DataFest. I think after his talk, we will not have this kind of problem. I hope someone will take a photo of him. But anyway, we can pass someone's face, someone's picture or something's picture into this network. For example, in OpenAI DALL-E, if you ask him to generate a flag of Armenia on the building of the embassy, okay, it will fail to like reconstruct the correct flag. It will remember like all of these colors, but not in the same order. So basically, what you can do is you can like pass. It can automatically find Armenian flag from database and put there, and it will only left to like generate the rest, and it will like copy all the things you have. And even if you give someone's face, it is not like required to copy it. It can like draw from different angles. Okay, so another things, like this is my last slide. Few things are unlocked after this like approach. First, interpretability. So in deep learning, we have this problem with interpretability. We can't explain what happens in our model. Here, what we can do is we can pass the input, like get the output, read it. Okay, after that, if you want to know how does that happen, you just can like programmatically read the retrieved articles. And it's like kind of it shows you references that you need to know, like how it answered that specific question. Okay, efficiency, as we discussed, like 20 times less parameters, like significantly less compute on the training. Larger factual knowledge is possible. How? You can train the model, and after training, you can increase your model's knowledge base. And you can increase that, in fact, over time. And you can add this information about 2020 US elections after that. By the way, I asked OpenAI who invaded Ukraine, and it said Russia invaded Ukraine in 2022. Okay, it's like you don't have to know knowledge base in order to guess that. So after that, you have this. So you have this editable knowledge. So you can not only add new knowledge, but you can also edit. For example, you can write down that, for example, Donald Trump is dead. Yeah. Then you can do it dynamically. So basically, as you have like very, very large knowledge base, you can just take not like 10 retrieved examples in order to compute, but like 2 of them. If you are, if you want to do this like more affordable way, but you can, if you want to like pay more money in order to have higher quality generation, you can still do that. This is also good for few-shot, because like, I mean, in few-shot, we think that many tasks already have their supervised counterpart in the internet. So basically, it can automatically generate training data for you in few-shot space. And in some cases, for example, in ImageNet, we have thousands of examples, and you can't actually write down all the label names even in your context in order to make your model to predict from those class names. And what you can do there, you can retrieve from this K and K-shot data set and retrieve the best examples from it and put in the context, because the context of language models is almost always limited. Yeah, and in-context learning is also improved, because like sometimes when you do a pre-training, you are just putting random sentences like in the same batches, in the same contexts, in order to increase the performance. But what you can do, you can use the very same retrieval mechanism in order to make in the training data to make closer, like similar things, similar concepts happen in the same context. So the model is getting used to the fact that it has many knowledge pieces in the different parts of the same context. And that's it. Yeah, thanks.
Okay, so basically we all know that there's like a coffee break happening there, but here you have Karan. Can you show us the last slide, the previous slide, please?
Yeah, this one.
Here are lots of things that Retrieval-Augmented or Retrieval-Concept learning can bring. So I'm anxious to hear your questions to Karan, and feel free to ask anything. I also have questions to him, because but I first want obviously to give venue to all of you. So, what's going to be the first one? Oh, you are so fascinated that you are speechless after current talk.
I guess everyone just wants to drink a coffee with me.
That's a, a good point. I mean, okay. Let me ask a question. Just to give some context, I'm from DeepPower, where we also work on different kind of question answering systems. We have ODQA, which is open domain question answering, and knowledge-based question answering.
Mm-hmm.
So one of the things that came to my mind yesterday when I was thinking about what you're going to talk about was, have you looked at what Blunderbot folks at Facebook were doing for their approach to retrieval-oriented or retrieval-enhanced learning?
The answer will be very short. Honestly, I don't. I don't know a thing about how the Blunderbot works.
Okay, I mean,
I can't really, yeah.
Okay, then I definitely recommend you to take a look, because like Blunderbot is one of the few bots or AI assistants, if you like, in a way that incorporate retrieval enhanced learning into the way how it responds to people's questions. Okay, maybe someone else wants to ask a question now that I got you warm up. Go. Hi. How are you?
Yeah.
Nice to hear.
So how do you see retrieval actually being in different aspects that you mentioned for the coming like 5 years? Like not the current research that is developing. What is like the direction that retrieval is going? More memory, maybe less.
Yeah. I think this size of the memory, I think it's like right now limited only technically, but I'm more of interested in research that will kind of make language models to do, say we have these join statements in SQL, right? So basically, I want language models to model even that. So basically, it can treat all the knowledge in this universe as a relational database and query on them. So basically, if joining them is possible.
What do you think of retrieval as an auxiliary task, like to MLM, for example, or like common training task?
In all of these papers, especially in retro paper, they discuss that using retrieval is always good. Like it increases the efficiency, and as I mentioned, it also makes the in-context learning way better.
How do you think it actually hinders interpretability? When you retrieve, you get an exact pattern.
Yeah.
How does that augment my interpretability and maybe?
Yeah, the problem is that it's not like making fully interpretable our models, right? But at least what you can do is you can get some paper that he builds his like prediction upon. So basically, after knowing answer to your question, you can have some references that you can use to go there and check. So this is kind of it is not like explaining everything that is happening in the network, but instead you can use the same information. You can just have this as a shortcut to use the same information to do your own research, to answer the question in your way.
So do you think retrieval can actually be used for multi-hop reasoning or neural theorem provers, something of that kind?
As I mentioned, there is like in this join, when I mentioned the join statement in SQLs, problem is to do this step-by-step hops, right? So basically, it's very, very connected to that, but I really don't know right now how we can accomplish that, because I mean, like it will be very, I guess, like if the number of all the knowledge parts is like n, you get n squared complexity, and I don't know how to deal with that. Maybe we have to do some kind of sparse things to achieve that.
Thank you.
Any other question? Thank you very much for yours. Yeah, go ahead.
Yeah, maybe I've missed that part, but do you know some real-world applications that use retrieval-based models in production?
I think BlenderBot is like I just heard about it.
Not real. I mean, BlenderBot is
Yeah.
also an experimental project from Parlay.
Mhm.
But in a way, what you described looks a bit similar to how Yandex explained how their search was happening in the real time. So there might be some similarity to that. Because you still need to have real data surfaced to a user in a very, very limited amount of time. And then you have to use a ML model to retrieve the right answer from the small corpus of data you retrieved when user issued a query. So that's one of the ways how you can utilize this approach.
Oh, like,
But that's a good question.
I can imagine like help chatbots, like support systems where you can like go to the website and like ask the support. That can be like a good assistance, like for
Yep.
instance, domain specific.
And-
Yeah, you can like build.
Yeah.
Sorry, your
Yeah, and after finding the correct answer, you can again provide some documentation links to browse. Yeah.
Okay. Pretty good. Does anyone else have a question? Okay, I mean, then I want to say big thanks to Karin for bringing all us up to speed with what's happening with, oh my God, with the use of retrieval to do all of the things here. I just hope that we can see more of these things used today. Just to give some small context, you, for example, I mean, the biggest limitation here is what's happening at the first stage when you do retrieval. That's the trickiest part. You still need to have a good algorithm to find the right context.
Yeah, and this retro paper was all about that. That if you can scale it, like 2 trillion parameter, 2 trillion tokens, they claim that even using just frozen bird to find the k nearest neighbors as the best retrievals, it works much better than any of the previous research. So scale matters actually in this case.
Okay, well, Karin and everyone, thank you so much. And now it's your opportunity, golden opportunity to have coffee with